Hi there everyone. Welcome to the video lecture series on Z transforms. I am Mayur Gohil. In this video lecture, let us begin with the definition of Z transform. It says that if we have a sequence f of n where n is in natural union with 0, this means it is set of whole numbers, okay? Set of whole numbers. Now, some places or some texts you would see the notation of whole numbers with n naught, n suffix 0, or sometimes it is written like this n singleton 0, 0 attached to the notation n. So, if we have this sequence where n is belonging to set of whole numbers, then the Z transform of f of n is denoted by capital F of Z, and it is defined as follows: Z transform of f of n is equals to summation n going from 0 to infinity operated on, or summation of f of n times z to the power minus n, which is equals to f of z. Okay, so this is the definition of Z transform. Now one very important thing here it comes is Z transform, which is defined over here in this equation 1, is called a unilateral or a one-sided Z transform. Now why it is one-sided, it will soon be revealed. Here if we have 0 over here and the infinity on the RHS side and minus infinity on the other side. So because our n is running from 0 to infinity, it is on the right hand side, so that is why this is called one sided Z transform. Now we see a bilateral Z transform definition. Here we observe that n is running from minus infinity to infinity. The definition is absolutely the same, but only the difference is that n is going from minus infinity to infinity. That's the whole difference. We shall be throughout using the following definition of Z transform. uh, Wherever we would use the bilateral Z transform definition, we would mention it. Otherwise we shall always stick to the unilateral form of the definition. Okay, now one very important thing to note here is that this variable z that we see, okay, or the one even in the definition, okay, this one is a complex variable. Z is a complex variable, as I have mentioned here below. So that is what is very important. And now let us go further, that this z, which is outside the capital Z, is a Z transform operator. Now, some books use a cursive Z, or some places you will see a fancy Z is there. You just have to be very clear while writing. If you are writing a cursive Z or a different kind of Z, be very careful. Just hold upon the notations clearly and write it without any mistake, because there is capital Z or a cursive Z, there is a small z also involved in solving. There is a function or a sequence f, small f notation is there, and a capital F notation is there. This notation, once you are able to digest the whole things will settle down clearly. So try to understand these notations carefully, and then the whole process follows very smoothly. The next thing, a very important property, is linearity property of Z transform operator. The property says that if we have two sequences f of n and g of n such that they can be added, and a and b are constants, like both simultaneously won't be zero, but if they are constants, then Z transform of A f of n plus minus b times g of n is equals to A times Z transform of f of n plus minus b times Z transform of g of n. Okay, so this, if you further simplify, this would become capital, so A times capital F of Z plus b times capital G of Z. Okay, so accordingly the whole thing would go. Now this is very much similar to that which we have always seen in our basic concepts, in which, like, if we take derivatives, derivative sign distributes over the addition and subtraction and the constants come out. So that's what the whole property is there. Here we can have plus minus. Okay, so that's this linearity property about. Now let us go to the important part after this, that is region of convergence. Now when we saw the prerequisites formulas that were 1 upon 1 minus z is same as summation, right, summation z raised to r running from 0 to infinity, when we said, and there was a condition over here. The condition said that here we had mod z less than 1, right? So this condition that is there is called ROC. This is ROC. If this ROC changes, then we would not be able to get the same answer, and the things would change a bit. So that is why ROC is very important all across the chapter of Z transform. So what does it say? That for any given sequence, the Z transform may or may not converge. That means we may have a Z transform for that sequence, or we may not have. The set of values of Z, or equivalent the set of points in Z plane for which f of Z converges, is called the region of convergence of f of Z. Now if there is no value of Z for which f of z converges, then the sequence fn is said to be having no z transform. This is basically the whole process, because ROC may not be there. Okay, now these are certain advantages that you would see uh, for Z transform. Now if you have dealt with different domain of topics where Z transforms are used, then these advantages you would realize why these Z transforms are important. The first is where difference equations are dealt. Then there is convolution in time domain is converted into multiplication domain. Now all these complexities that we see, okay, that calculations becomes very difficult. Nowadays we have computers to handle all that. So computations are very very important, and uh, in order to save time, when these techniques were devised, all these techniques were helping out a lot, because the analytical way is slightly uh, proof oriented, and it is more strict to the domain of solving, and you need every time you need a proof. So all these things are taken into consideration, and these transforms, when they were found, so they helped a lot to reduce the time as well as the difficulty of solving. So Z transform exists for most of the signals on DTFT. So now if you have ever dealt with DTFT, you would realize all these concepts are very much there. And then Fourier transform is nothing but the Z transform evaluated along the unit circle in the Z plane, and the frequency response can be determined. All these things are when you deal with engineering concepts, you would get all these things in detail, or if you deal with Fourier transform and other topics, you would see all these things. Okay, so right now in this video lecture, I have given you the absolute basics of a region of convergence and the definition and what we would need throughout the topic. The definition is the most crucial part. ROC I will keep on dealing as and when we need. The largely the ROC part will be needed when we go for inverse Z transform. That that is where its role would become extremely major. So that is the time we would see in great detail. Till then, keep solving good amount of mathematics. I shall soon see you in other video lectures.